here with my younger brother, who is an amazing engineer who started creating at the age of 4. Now today we're going to walk you guys through his creative process, things he wants to implement in his projects in the future, and future projects that he hopes to complete as he continues learning and growing through this process. So Jason, do you have anything to say?
I hope you guys enjoyed this video. We took a lot of time to put it together. I hope you enjoy.
How is each piece manufactured and assembled into the final product?
Well, I use my 3D printer to 3D print the parts, where I have designed those in Fusion 360 or Tinkercad beforehand. Then I'll print those out, then put them together. And of course, some parts may not fit, so I'll have to redesign them to make the robot even better, like I am doing now.
Oh, can you describe the process you use for writing a piece of code for these wonderful robots?
Start with the basic parts of the code, then move on to more complex parts.
All these robots are amazing, and you're only 12 years old, which is insane, and you can code and build robots. So where did all of this start?
Well, originally I wanted to find a fossil in my backyard, which I quickly understood that it was impossible for me to do it with my little shovel. So then I decided that I would create a little drill. So then I used a simple DC motor to a battery. Then I hooked that up to a little drill bit that I made, and then covered it all in masking tape. Then quickly
and colored it.
Yeah, and colored it. Then quickly realized it looked kind of like a lizard, so that's just what I went with. In the end, it did not work as efficiently as I hoped, but it was definitely a spark of something new that would be very interesting in the future.
What did you envision when you were creating these robots, and how did the outcome reflect that? And is there anything that you would do better?
Well, there's a lot of different improvements or upgrades that I couldn't do, or with the knowledge that I have now, I would have definitely done earlier. Such as adding stronger motors or making the design overall better. And originally I envisioned this to be, my dog robot to be similar to a robot by Boston Dynamics and MIT with their quadruped robots. In the end, you can see that I was definitely inspired by them, but definitely not up to their standards yet.
And then what about your snake robot?
My snake robot was inspired by someone who built a similar-ish robot with an Arduino board, and I thought that was pretty amazing. So then I did, some more research. Then I saw that Carnegie Mellon, another college, had created a similar kind of robot. So then I was pretty inspired by those two things.
Sweet. What did you learn throughout the process and along the way of your journey of creating these robots, and how did it help you better them as you neared the completion of the project?
Well, I did learn a lot of different kinds of skills, which are like designing in Fusion 360, programming more and more in C++ and Python, as well as learning a lot more geometry and trigonometry. And I've learned a lot of things, and now know that there are a lot of things that I could potentially add to these robots, such as high-powered motors, better battery system.
How does this robot work? Could you give us a rundown and some of the components there, and how each of them are used in this robot, and how it's beneficial, how it's not, and things like that?
Okay, so this right here is what you would know as the tail of the snake. So right here is a servo motor, which is just simply a motor where I can specify the degrees or angle that it should be at. So right here would be its home position at 90 degrees. Right here would be about at 180. Then here would be negative 180, alright? Then if we move on along, it's just the same pattern over and over again. And as you can see, these wires are getting thicker and thicker, and that's simply because this motor right here is sending the wire through here. So it's this one, and this one. So then all of these wires are soldered together and then just simply get thicker and thicker.
Are they screws?
No, these aren't screws actually. So I could add extra stability to these motors. I added this bottom piece that spins along with the servos as well.
And why are there wheels on every other component?
Okay, so first let me explain what these wheels are here for. As you know, snakes have scales on their belly. Of course, I could not get real snake scales, so I had to improvise with these wheels. These wheels don't have any motors in them whatsoever. They just simply spin if you put any force on them. They restrict side-to-side motion and allow easy forward motion and backwards motion, which is very similar to how snake scales restrict side-to-side motion and allow easy forwards motion. So that's why I have these wheels here. Then you did ask, why do I have them on every other segment? Well, that is because I figured this out during tests, that this robot isn't perfectly calibrated to be straight. So if it's at an angle like this, one part of it will be lifted off the ground slightly because of the not perfect calibration. So then if I add all of the wheels on there, the snake robot will actually
topple over.
Yeah, it'll fall over onto its side, which of course isn't very good.
Now, how does it look under all of those wires and motors? What's on the bottom?
Well, right here on the bottom, you can see that I've simply just used some Lego wheels because those spin very freely and are great to use because they're really simple and I don't have to 3D print anything with spinning parts, which of course, if you 3D print, you would know that it could be a hassle at sometimes. And then right here is the top of the motor. This connects to the bottom of this so that it can spin the rest of the machine. Because if this were not connected, there would be no reason that this part would move. It would not be connected whatsoever.
Right, because the white plastic piece is what turns when the motor has started. Correct?
Yes, this is called the servo horn. The servo horn.
And did you make these motors or did you buy them?
No, I bought these motors for about $20 for, I'd say around 10 of these. They're pretty cheap and pretty easy to get your hands on.
Now, walk us through the complicated look of the head. What is going on in there?
Okay, so this, of course, like Sharon mentioned, is the most complex part of this snake robot. This is where all the computing and mathematics is going on this robot. Okay, so we've simply just flipped over the robot onto its side so you can see the underside of its head. So right now, what you can see first off is this module right here. This is a Bluetooth module, so I can control this robot with an app on my phone using Bluetooth. Then, right over here is the LiPo battery charger. So this simply charges your battery, so you just have to put a 5-volt supply in this micro USB slot. Then if you can see right here, under its charger is the LiPo battery that powers this whole robot. And sadly, since this robot's head is concealed, I cannot show you the insides of its head, but what is in there is this microchip. This is an Arduino Nano. It controls the whole entire robot using only a couple of pins and connecting all of the servos directly to this, which is pretty powerful if you think about it.
What are the pins?
The pins are where we connect different wires to the module.
Are they soldered on?
Yeah, you can solder them on. Yeah, this is the reset button. So if you told the robot to blink 20 times, then if you press this button, it would do that again. So this is the reset button. So it starts the code from the beginning. There, on the underside, there are more microchips and so on and so forth.
All right, what else is in the head?
In the head, I think that's about it, other than a couple of wires and also these LED lights that I simply put on there for fun. And this is the Bluetooth module that I used on the underside of the snake robot. It's a simple module with only 4 connectors, so it's really easy to get a Bluetooth communication with your robot.
All right, now where do you upload all the code?
I upload all the code directly to this chip with this port right here from my computer onto here. It's really easy to get started with Arduino, and I would highly encourage you to try it. because after you try the blank sketch a couple of times, you can go into more and more complex code, then even make something similar to the robot I have here, or even better.
Thanks so much for watching the video, guys. I really hope you enjoyed it. Don't forget to hit that like button, subscribe, hit that little bell on the side so that you get notified when we post a new video, and make sure you come back for more anatomy, algebra, and
robotics projects.
Alright, we'll see you guys soon. Bye! Oh, and don't forget to never stop enjoying the process of learning, and just learn, grow, and inspire everyone. Alright, I'm done. Bye!